Okay, today we are going to discuss the flow graph. Before that, we discussed several concepts. The first one is node and branch. The flow graph looks like this. We have this, and the signal flowing in, and this transmit this here, this is out, and this is in here. So this is node J, and this is node K. And we are going to write this is Wj, and this is discrete system, so the time is n, and the value at this point is Wk, it's function of time n. So this is node, all others are branches. If a node has no entering branches, then that is called a source. For example, if this is node and this is branch is out, this branch is out, and if there are other branches are out, but there's no branches entering into this, this is called the source. Obviously, this is source. And similarly, if with a sink, so this is the source, and the other one is a sink, then it means all branches are entering into the node, into the sink. This is one. Another one is looks like this. So we have xn here, and we have this, and we have this, and we have another node. This is input xn. This is w1n, and this is w2n, and this is the output, which is the sink. So this is the sink. This is the source. And the signal flows from here to this, and also from here to here, and multiplied by a constant d. That is this very similar to what we discussed last time. So this time multiplied by constant d. So yn equals xn times d, constant d. And we have go this way. This is b, and we have another one this way, and this is c, and we can have another one branch this a, and we have this here. Go this way and multiply by e. So both this and this are flow graph. Okay, next we have an example. I can remove this, erase this. Signal flow graph. So we have an adder, and we have this input, and we have branch this way, here, and this is B0, and we have adder this way, and we have a unit delay, and we have here, this is B1, and we have this branch A, this one B1, and this one is B0, and here, and this is the output of the system, this is the input, and here is the intermediate value, it's Wn. So this is a block diagram of the first order digital filter. We are going to convert this diagram, block diagram, into the flow graph. So how to draw this? Convert this one into some flow graph like that. And let me use this. We have this xn, and this is node 1, and this is node 2, and this is node 3, and this is node 4, and this is node 5, and this one yn here, this is xn. So from 4 to 1, here, this is 4, this is 1, 2, 3, 4, and 5 here. And we just multiply a constant a here. So this is a, this. And from 2 to 4, that is a unit delay. So it's called delay branch. And from 4 to 5, 4 to 3, okay, I move 3 to a little bit closer to this. This one is multiplied by constant B1. And from node 2 to node 3, there's a coefficient B sub 0. And from 3 to 5, that is 1, because that is connected directly. And this is W1, this is W2, W3, W4, W5. And we are going to write out the relationship between the input and the output from this signal flow graph. So first one, what is W1? W1, you can see W1 here equals A times W4. So this W1, W4, W2, W3, and W5. And this one, this signal going in. Right? So the value here will be equals this value plus this value. And we have also signal flow this way. We only consider the incoming signal. Right? So the value here equals this because this comes in, and equals A times W4 because this comes in. And don't consider this because this is out. Does that make sense? Right? So W1 equals Xn. Sure, this W1 is also function of time. W1n equals Xn plus A W4 as function of time. Any questions on this? Alright, good. Now, what W2? What is this? Can you tell me? Keep in mind, only consider the incoming signal. We don't need to consider the exiting. So there's only one branch entering into node 2.
W1.
Yeah, W1. Okay, so that equals W1. Everybody sees this? Okay, good. Then what is W3? W3 is here, and this one goes out also. So we have 2 branches, incoming branches. So what is it?
B0.
Okay, B0 times W2, right? Then plus
B1.
B1 times W4. Right? That's all very straightforward. Alright. How about W4? We don't need to consider this one because this is out. We don't need to consider this one. This is out too. We only need to consider this one. And the function is unit delay. So that means W4 n equals W3 n minus 1. Is this good?
Shouldn't it be 2?
Oh, sorry, yes, you're right. Okay, W2, good. W2 n minus 1. Yes. Okay, the last one, the output Yn equals what? Yn is here, equals just W3, right? So W3. Alright, so we have these 5 equations, relationships relating the input, output, and all the internal node values. We can we need to use the elimination method to eliminate several intermediate values. So we have W2 here. W2 equals so W2 equals this, and equals W1. W1 equals xn plus this, so equals xn plus a times W4. A times W4. W4 is W2 divided by 1 time. So W2 divided by 1 time. Everybody see this? So W2 here equals W1, which is xn plus a W4. A W4 equals W2 n minus 1. Then we have Yn, the output equals output here equals W3. W3 equals this, which equals B0 times W2n, then plus B1 times W4. Okay, W4 is W2 divided by 1 time. W2 divided by 1 time. Okay, so now we relate, we have this 2 equations. We have 3 unknowns, x, y, and W2. Definitely we cannot solve them because we have only 2 equations. But we can represent, we can eliminate W2, and we can have a relationship between x and y. So this is how we find the relationship between the output y and the input x. Does it make sense? Okay. So let me summarize. You are given a flow graph. You need to write out all the relationships between the input, output, and the internal node values. So you are going to have a lot of equations, and we are going to eliminate all the intermediate node values. Then we have only x and y left. So we get a relationship between the input and the output. Okay, so we have the next is once we are given this flow graph, how to find the system function from it. System function from flow graph. Okay, we are given an example here. This is the input xn. is node, and we have this. So this node is W1n, and this node is W2n, and this is W3, and this one here is W4. This is the output. Right? This is -1 here. This one is A. This one is Z to the -1. And from here, connected to this. And from here, connected to this. Right? We are given this flow graph. What I want is the system function, which means the Z transform of the impulse response, or the relationship between xz and yz. Okay, we just follow those steps. Find the relationship between all of them, write out the equations, then eliminate the internal values, then we have only x and y left. Okay, first one, W1n equals what?
X and
We have this one coming in.
X
W1 and this one.
Is it X and delayed by 1?
This one means multiply by
Oh,
-1. Delayed means
okay.
z to the -1. So we mentioned before, we prefer use z to the -1 means delayed by 1 unit, but 1 time. So this -1 means multiply by, the coefficient is -1.
So negative xn?
So that is -xn. -1 times xn, right? That's all. We need to consider all incoming branches.
Plus W4?
Plus W4, right? Plus W4. That's all? Yes, okay, good. Alright. Next one is W2n. W2n is here. How many incoming branches do we have? Only one, right? This one. So that equals A, W1. Then next one is W3. W3 is here. How many branches do we have? 2. This and this. So equals what? This one. We don't have any number here, means that equals 1. So that equals xn plus this. And we don't have any number on here. So that means this is also equal to 1. So plus W2. Okay, now you tell me W4.
W3 and -1.
Okay, equals W3 n minus 1, right? Okay, we please distinguish between this and this. This is times -1. This one is deleted by 1 time. That's all? Yes, we have only one coming branch to node 4. Right? That is there. Okay, next one is the output yn. The output, which is here, equals what is it? W2 plus W4. Yes? Okay, now you need to use any technique you can use to eliminate W1, W2, W3, W4 and have only X and Y left. Then we get a relationship between X and Y. There are many methods to do this. You can start from any formula, but we discussed the one I have here. So W1 also I can write in, this is in time domain. In time domain. I can write in time domain here, just like this, like here. Or I can directly write in Z domain, take the Z transform. The only difference is this one is WZ, W1Z, this one is negative XZ, and this one is W1Z times A, and no big deal for this. The only thing we need to care about this one is this. What is this?
Z to the negative 1.
Z to the negative 1
W3.
times W3Z. So from here, right, we should be able to change in time domain, delete by one time, to in Z domain, Z to negative 1 freely, and no big deal, right? So you should be able to do this very quickly. Any questions on this? Right? If this one is -2, that means that's Z to the power of negative 2, right? They are equivalent. All right, so we write directly in Z domain. So this one, W1Z, this is parentheses. This is a square parenthesis. Right? Equals what? Right? I can write W4Z minus XZ. It's good? Yes? Tell me. All right, W4. Okay, switch position doesn't matter, right? It's good. Okay, then the second one is W2Z equals A times W1Z. The next one will be W3Z equals XZ plus W2Z. And the next one is W4Z. This equals, alright, be careful for this. That is Z to the negative 1, then times W3Z. And the last one is YZ equals W2Z and plus W4Z. We have these 5 equations in Z domain. We said in here, in time domain, we can eliminate directly, right? W1, W2, W3, but it looks like there's a delay here, not right? Like in here. So not that straightforward. But from here, you can see this is very simple. Right? So we have W1, W2, W3, W4 as intermediate. So we just eliminate. So let's see which one we will want to eliminate first. Alright, looks like we can eliminate, we plug this one, W1, into here. Right? So W1 equals W4 minus this. So this is only W1 here, in addition to this. So we replace this W1 with this one. So this one will be gone because we don't need to use this one. So W2 equals A times W4 minus XZ. So now we have only 4 equations left. Right? Then you can, looks like we can eliminate 4 here, right? Because 4 equals this. So we plug this one into here, and we plug this one into here. So 4 will be gone. So now we have this, and these 3 left, which we have only W1, W2, W3, X, and Y. So we do this step by step. Can you do it? Yes or no? It's very simple, right? You just need patience. But anyway, I won't bother you with all this time-consuming things. Alright, so let's see. Finally, at last, you have only one equation, which is sum x equals sum y. Sum x equals linear combination of x, z equals some linear combination of y, z. So we need to collect terms. So we are going to have the system function defined by yz over xz here, and you do this by yourself, and it is equal to z to the negative 1 minus a over 1 minus a z to the negative 1. You can try by yourself after the class. Right? I hope this is correct. If it's not correct, let me know. Okay, so this is the system function. We obtained the system function from the flow graph. So later time, once you are given a system, you can easily draw this signal flow graph. Then you just use this method try to find the system function. You don't need to write this here. This one is only for us easy to see. Okay, we get this from here. Or you can just write directly from the z domain here. So that's this one equals this about xz or something, and plus w4z. So you can directly write this in z domain. Does it make sense? Alright, this is the system function. So the next question is, what is the impulse response? Impulse response means if the input is an impulse, just only equals this, what is the output? We just need to take the inverse z transform from here. Can you do that? Okay, I don't think you need to do anything other than tell me directly what this is inverse is. Okay, so here, Hn equals what? Obviously, we need to break this one into two terms. First term, second term. Okay, consider the first term. What is it? Right? The first term is this, z negative 1, 1 minus a z to negative 1, right? Okay, forget this first. Consider this one as 1.
It's just a un minus 1.
A to the n, un, right? Now, you multiply this means delayed by 1 time. So this term will be equals a n minus 1. It's supposed to be an for this, but delayed by 1 time. So a to the n minus 1. And u n minus 1. That's the first term. Make sense? Okay. The next one is this. So minus a and times what? This is z to the negative 1. This is a. So still a n u n, right? But multiply by this a, so that is plus 1 u n. Any questions on this? So if I give you a flow graph, or you get a flow graph from any system, follow these steps, try to find the system function and the impulse response. I believe we have homework problems to practice this. We are going to stop here, and next time we are going to discuss infinite impulse response and finite impulse response systems. Yes, question?
On the homework, I think it asks us to find the purpose of the system. Would the system function that you have right there be what we're looking for?
The system function, which one?
Like Hn equals all of that.
This one?
Yeah.
What's your question?
Is that what we're looking for when the question's asking us to find the system?
If I ask you the system function, okay, you stop at this point.
Yeah.
So Hz, this is a system function. It is the Z transform of the impulse response. We are doing this here is okay, further step from the system function. I want you to see what is this system in time, impulse response.
Yeah.
So if I ask you only the system function, you stop here. That is good enough. If I ask you what is the impulse response, then you still need to go here. Then just take one more step, find the inverse Z transform. Then that is the impulse. This is the impulse response. And this is the system function. Next time we are going to discuss systems based on the different type of impulse response. For example, if we have an infinite response, the input is an impulse, your response will have an infinite in time. That is called a IIR, infinite impulse response. If the input is an impulse, but your output is only limited in time, that is called a finite impulse response system. We are going to discuss this next time. Okay.